I read an article about the Webb telescope, and what they were taking into consideration is the possibility that the Big Bang may be incorrect, and that the universe might be larger and older than we think.
So, I hesitate to ask what pages on the internet you hang out on.
It was a legit. It wasn't saying the universe is older. It's saying as more data and new information comes in, there is a distinct possibility that the Big Bang might just be it just might explain the reach of the technology and not the actual scale of the universe itself.
Okay, so the way to think about this is, and this is the way science has worked since basically the year 1600, where Galileo sort of starts codifying what people knew probably should be happening, but no one really did it in large scale. If you have an idea about something, then you test it multiple ways and get other people to test it. And if the tests give you consistent results, you have a new understanding of the universe. When that happens, that knowledge of the universe doesn't go away. It doesn't get undone. What happens typically is you have a deeper understanding of the universe in which that understanding gets embedded. And you realize that you only understood a small part of a larger whole. But the small parts you did understand, where you had multiple experiments that confirmed it, that doesn't change. So the cleanest example of this, and I'll get back to your question, is Newton's laws of motion and gravity. Did anyone see anything move faster than a galloping horse in his day? Probably not. And so the Newton's laws of motion and gravity worked. They worked not only for galloping horses, it worked for the moon in orbit around the Earth, and the Earth in orbit around the sun, and Jupiter's moons in orbit around Jupiter, all right, and for the planets. So, okay, but wait a minute, it doesn't work for Mercury. Mercury's orbit is not following Newton's laws. Is there something wrong with the data? Let's check it. Data's correct. Oh my gosh, what's happening? Einstein comes along and says, I have a new understanding of gravity and a new understanding of motion. And it accounts for this weirdness in Mercury's orbit.
What was the weirdness?
Its shape was not exactly what Newton's laws of gravity would give you. Its shape could only be accounted for when you throw in Einstein's theory of general relativity. Why? Because the sun's gravity is so monstrous and Mercury's orbiting close enough to it that it's being influenced by extra phenomenon going on in the universe that's the product of very high and significant gravity. And so then do we throw Newton out the window? No, actually. You know what Newton's laws are? They're what Einstein's laws look like when you put in low speeds and low gravity. If you put in low speeds, they become Newton's laws. In that limit, Newton's laws don't stop working where they used to work. Apollo to the moon used only Newton's laws because Einstein didn't matter at those scales. The moon and Earth and rockets, we're not going fast enough for any of that to matter. But when you start going fast enough, you cannot use Newton's laws. You have to use a deeper understanding. Now, where does Einstein take us? You go into the center of a black hole, you get black holes from Einstein. Center of black hole is a singularity. All the theories say the matter occupies zero volume, thereby having infinite density. And that's kind of weird. What? No, you can't have infinite. No. That's a limit of Einstein's theory. That's where it breaks down. Some have joked that's where God divides by zero. Remember in math class, you can't divide by zero.
Right.
It's not defined or not allowed. So in Einstein's equations, we're dividing by zero at the singularity. So we all know that as brilliant as Einstein was, and as successful as his general theory of relativity has been, it has limits. And one limit is the center of a black hole, and another limit is the very birth of the universe itself. Getting back to your question, the Big Bang. So we have top people working on trying to resolve this singularity problem. And in so doing, you get to some ideas that, well, maybe our Big Bang, because the Big Bang is not going to go away. All the data support this. So now I've got this Big Bang thing, okay? And Well, is this embedded in something bigger?
Ooh.
So when you put like quantum physics and general relativity and you try to come up with some bigger understanding, deeper understanding, string theorists have been all into this, you get a multiverse. We didn't pull that out of our ass. That came out of the equations. So how old is the multiverse? I don't know. It's definitely older than our universe because it birthed our universe and it births other universes and it births, the way the equations drive it, an infinity of universes. This is the idea that maybe there's a version of us in another where I'm bald and you got the afro and but everything else is the same.
And also a version where everything's the same.
Where everything would be the same, yes.
Everything you've ever said has been said before exactly in the same order.
Correct. There's no reason to presume that everything in this universe isn't or hasn't already played out in the exact way in another one of these infinite universes.
And in an infinite number of different ways.
Correct. And so that is what comes out of the equations. So that makes the Big Bang a kind of a small part of a much larger whole. And so, yeah, we're ready for that. But the fact that the universe had a beginning 14 billion years ago, and there's the cosmic microwave background, all of these features are intact. They're not going to all of a sudden not apply. That's my point.